welcome. Functions and sequences. A function is a rule that assigns to each element from a set A, called the domain, only one element from a set B, called the codomain. So we have a domain, a codomain, and a rule that assigns to each element from A one element from B. So we set the definition as follows. For any x, this means for any x in A, there is only one y in B. Y is equal to fx. The values that the function is taking, the images 1, 3, 4, and 6 in this example, together forms a set called the range of the function. And here are the values, the images of the function at A, B, C, D, and E. Here's a typical example of a function when you have a set class roster, a set of students, and here are their grades. And you see every student must have one and only one grade. And more than one student can have the same grade? Yes, why not? Like in this situation here. Mike and Caroline and Brian, they all got B. No student should be left without a grade. We shouldn't leave a student here without a grade. And not all grade must be assigned. Not necessarily that every one of these grades should be assigned. Here are some other examples. Square of x, as x squared, is a function from R to R. The range is the set of positive, non-negative real numbers. Here is another function is in mode 7. It's a function from the set of integers to this set. This is the remainder of the division when you divide n by 7. So the remainder will be 0, 1, 2, 3, 4, 5, or 6. Another function, fx is equal to log 2x. That's a function from the set of positive real numbers to the set of real numbers. Here are some special functions. Is onto function is a function where for any y in B, there is an x in A, such that y is equal to fx. In this situation, you can see that the range is equal to the codomain. And easily you can notice that the total number of elements in B should be less or equal the total number of elements in A, if A and B are finite sets. Here's another kind of functions. It's one-to-one function. It's called also injection. The other one called surjection. This one is called surjection. This one is injection. It's a function from A to B whenever x1 and x2 in A different, their images are different. In this situation, the total number of elements in B is greater or equal than the total number of elements in A, and if A, B are finite sets. Now, when a function is at the same time one-to-one and onto, one-to-one and onto, this one-to-one onto function, it's called bijection. In this situation, the size of A and the size of B are the same. We say the cardinality of A and the cardinality of B are the same, provided that A and B are finite sets. Here are here's a summary of these kind of functions. This one here is onto, but not one-to-one. See, not one-to-one. These 2 point to A and onto. This one here is one-to-one, but not onto, because of this is left here. This one here is not one-to-one and not onto, This one both one-to-one and onto. This is not a function because you assigned to be two different images. It's like you're giving a student two different grades. It doesn't work. Now you notice in this situation, or this, or this, or this, if you reverse the arrows in here, you won't get a function because one will be pointing to two A and B at the same time. Here you won't be a function because 4 wouldn't have an image. Here is not a function either when you reverse the arrows. Only in this situation here, when you reverse the arrows, you get a function called the inverse function. Here are some examples. This one is from n to n. That's called the identity function. Is in is equal to n for all values of n. This one here is also one-to-one and onto, but it's different than the identity function. Here it's defined as follows. If n is n plus 1, if n is even. See, when n is even, we're adding 1. When n is odd, we are subtracting 1. So if n is n plus 1, if n is even, and n minus 1 if n is odd. Number 3, this is one-to-one, but not onto, because I purposely left this out. So 0 points to 1, 1 points to 2, etc. So this function is defined as if n is equal to n plus 1. It's one-to-one, but not onto. This last one is not one-to-one, but onto. See, onto is covered all of this, but not one-to-one. This violation here, 0 and 1 points to 0, makes it not one-to-one. How do you define this function? You can say if f of 0 is 0 and f of 1 is 0, and then f of n from 2 up is n minus 1. Here are more examples. Square x, x squared from r to r plus. Now I changed it to r plus. Now it's onto, but it's not one-to-one because -5 and +5 have the same image. -3 and +3 have the same image. Now, if I limit it to the set of non-negative real numbers, then it becomes onto and one-to-one. This function here, the n mod 7, from z into 0, 1, 2, 3, 4, 5, 6, this is onto function, but it's not one-to-one, because as you can see, in 9 mod 7 is 2, and 16 mod 7 is also 2. The function log base 2x from the set of positive real numbers to the set of real numbers is onto and one-to-one. That's the inverse function of the 2 to the power x function. Function inverse. If you have a function from a to b, which is bijection, which means on the same time one-to-one and onto, you can invert this function. The inverse function, f minus 1, is from b to a. F minus 1 is called the inverse function. So y equals fx is equivalent to x equals f minus 1y. See, x takes you to y by f, and f minus 1 brings you back to x. Here are a few examples. If fx is equal to 2x plus 3 from r to r, we need to find its inverse. Always set it this way. Y equals fx, x equals f minus 1y. So y equals fx, we put it here, and we solve for x. So you take 3 to the other side, y minus 3, you divide by 2. So x is equal to y minus 3 over 2. This x is this x right here, the same x. So you put f minus 1y is equal to y minus 3 over 2. Now you need to understand this x here is a dummy variable. So you can put t, t if you want. You can put z, z, y, y. It doesn't really matter. Here, we have y and y, but normally we use x as a variable. Then we replace y by x. We put f minus 1x is equal to x minus 3 over 2. It's a function from r into r is the inverse function of this function here. Another example, fx equals x squared. Again, from the set of positive real numbers to the non-negative real numbers to the set of non-negative real numbers. Again, y equals fx is the same as x equals f minus 1y. It's equivalent to that. So we put y equals x squared. Solve for x. X equals square root of y. This x is this function here. So f minus 1y is equal to, excuse me, square root of y. And again, here we use x as a variable, as the variable. So f minus 1x is equal to square root of x. It's a function from r non-negative real numbers to the set of non-negative real numbers. That's the inverse function. Just a reminder here, the logarithm function, base 2. The function y is equal to 2 to the power x. The inverse of this function is x equals log 2y. So this is 2 to the power x. This is the inverse function. So fx is 2 to the power x is from r to r plus 0. And the inverse function is from the set of positive real numbers to the set of all real numbers. Function composition. Now we have two functions, f from a to b, g from b to c. And I'm going to combine the two functions. This is composition. So I go directly from a to c using both f and g. You notice I put f first here because f is applied first and then g takes over. So we use this symbol, g circle f at x is g at fx. Here are some examples. One example now here. fx is equal to 2x plus 3 and gx is equal to x squared. Now I'm going to do g circle f at x, which is g at fx. You take fx and think what does f do? It takes a number 2x plus 3, 2x plus 3. Now what does g do? It takes the number and square it. So 2x plus 3 squared, you get this. 4x squared plus 12x plus 9. Now I'm going to do f circle g at x, which is f at gx. What does g do? X squared is x squared. And then what does f2 do? It takes the number, times it by 2, and adds 3. So I'm taking this number, times it by 2, and add 3. And you see these two are not the same. So the composition of function is not commutative. In fact, sometimes you can do one direction, but not the other direction. Here's another example. Find hx such that g circle h is equal to f, where f is given and g is given. So we set it up this way. G circle h at x is g at hx. Hx still unknown, but I know g, it takes a number, times it by 5. So 5 hx. So g circle h at f is equivalent to, is the same as 5 hx. That's this one here is equal to f, 2x plus 3. And you solve this for hx. So hx is equal to 2 over 5x plus 3 over 5. Now floor and ceiling functions. The floor function is a function from r into z. The floor function at x is the largest integer less or equal than x. The ceiling function is also a function from r into z. The ceiling function at x is the smallest integer greater or equal than x. So if x is here, the floor function is this integer, the ceiling function is this integer. Examples, The floor function at 3.2 is 3, and 3.9 is also 3. So we're not really rounding. You can think of it, we're rounding down. This one here, 3.2, the ceiling function of 3.2 is 4, and the ceiling function of 3.9 is 4. And these two functions are not one-to-one functions, are not one-to-one functions. This should be one-to-one functions. So floor function at x at 5 is 5, ceiling function at 5 is 5. Floor function at 1/2 is 0. Floor function at -1/2 is -1. Look at this situation here, -2.8. The floor function is -3. The ceiling function is -2. Now, floor and ceiling functions are very important functions, and I have a special video on these functions on my YouTube channel. So please go and check it out. Sequence. Sequence is a function from n or a subset of n into a set S. Here are some examples. an is equal to 1 over n greater than 0. You get these terms: 1 over 1, 1/2, 1/3, 1/4, 1/5, etc. Here's another example. Bn is -1 to the power n over n plus 1. We use this sometimes if we want to do alternating terms between negative and positive terms, because when n is odd, you get -1. When n is even, you get +1. And you see you get these terms here: 0 over 1, -1/2, plus 2/3, -3/4, plus 4/5, etc. Summation, when you see this notation, that's a sigma or summation from I equals 1 to 5. AI means A1 plus A2 plus A3 plus A4 plus A5. When you do summation from I equal 1 to n, AI, that means A1 plus A2 plus ... plus AN. Here's an example. We need to do the summation from I equals 1 to 5, I squared plus I. So what you need to do is replace I here by 1, and then by 2, by 3, 4, and 5, and add them. So you do that: 1 squared plus 1, 2 squared plus 2, 3 squared plus 3, 4 squared plus 4, 5 squared plus 5 equals 70. You add them, you get 70. Here is an example of double summation. So you have a summation from j equal 1 to 5, and summation from I equals 1 to 3. The easiest way to do that is to write it this way and do what is in this big brackets first, and leave this outside alone for now. So sigma from I equal 1 to 3, so I is kept as is. Here, when you replace j by 1, 2, 3, 4, and 5, you get 1 plus I squared, 2 plus I squared, 3 plus I squared, 4, etc. When you add those 1, 3, 6, 10, 15, I squared, 2, 3, 4, 5, I squared. Now you replace I by 1, 2, and 3. 1, 2, and 3. And you see here you get 15 plus 5, 20. You get here 15 plus 20, 35. You get here 15 plus 45, 60. You add them, you get 115. Here's another way of doing it. It's a little bit more longer, I guess. So you do, for I equal 1, you replace I by 1, and you make the summation over j. I equal 2, see, and the summation over j, and I equal 3, and the summation over j. So here, for this one here, you have to replace j by 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Here, same thing, 1, 2, 3, 4, and 5. So you do that and you add them, you get 20 plus 35 plus 60. Obviously, this method, this way is a little bit easier to use than this. And that is the end of functions and sequences. Thank you, and see you later.